I would like to thank everyone for joining the first webinar of the new SWAN Asia-Pacific Alliance. My name is Amir Khan, and I'm the Executive Director of SWAN, the Smart Water Networks Forum. I would like to begin by thanking Hugh Chapman from Pure Technologies, who helped organize today's webinar and will moderate the panel questions. Today's speakers include George Theo, CEO of Unitywater and Chairman of the SWAN APAC Alliance, Rob Dowling, Executive Manager of Customer Delivery at Unitywater, Dr. Gio Ning, Senior Manager, Infotech and Digital Transformation Department at PUB Singapore, and Mark Inisht from Watercare Services in Auckland, New Zealand. So what is the SWAN Asia-Pacific Alliance? Well, it's an initiative of SWAN, the Smart Water Networks Forum, which brings together leading players to accelerate the use of data-driven solutions in water and wastewater networks worldwide. The goal of the Alliance is to accelerate smart water and wastewater development in the APAC region through collective partnerships and SWAN's global expertise. Why join the Alliance? Well, it's free to join for the first year, and that includes free access to upcoming webinars, an annual workshop, and smart water case studies. SWAN members can also participate in the Alliance Planning Group and take a lead role in accelerating smart water adoption in APAC. Here's some more information to learn more. The Alliance is led by George Theo. Communications group is led by Hugh, Partnerships group by Rob, and the research group by Kesh Singh from Avia. Here is a list of current SWAN APAC Alliance partners, and we're now looking for more regional smart water players to join us in this Alliance's mission. Some upcoming Alliance events: we'll have a Smart Water Forum at Singapore International Water Week on July 11th, which I encourage you to attend. There will also be a Smart Water Pavilion at IWA's World Congress in Tokyo from September 16th to 21st. And this will be a great opportunity for SWAN members to have a discounted exhibition space and a free speaking opportunity. And stay tuned for upcoming APAC Alliance webinars and a utility workshop. I would now like to hand it over to Rob Dowling, who will provide some more information about Unitywater Smart Water initiatives.
A quick overview of Unitywater. As you can see, we're on the Sunshine Coast of Queensland in Australia. I describe us as a mid-tier water utility and quite young, I guess, in comparison to many others, and that gives you a flavour for our infrastructure in general terms there. If we just jump to the next slide, please, I'll go through these reasonably quickly to try and make up some time. So in the time since we've been formed, there's been a lot of pressure on reducing a cost to the customers, our $100 off the bill, and a lot of work has gone into that and forming the business, consolidating a number of things. We started, I think, with 12 SCADA systems and the consolidation that goes with that with the council amalgamations. Since our formation and the focus on reducing our costs, we've now moved into working perhaps smarter and not harder, and the embracing of technology and what that might be going to do for us. So if you look at the centre of the circle there in the diagram on the left, we're looking to be the lowest priced water and sewage provider in southeast Queensland, and the arcs that radiate out from that, I'm going to talk about two of those: intelligent operations and self-sustaining STPs. So if I just jump to the next slide, there's a lot in that, and I'll spend a little bit of time on this slide, and I'll go through them as quick as I can and just give you an overview of what sustainable sewage treatment plants means to us, and then move to intelligent operations. The two are inextricably linked, but I guess in summary, in terms of self-sustaining sewage treatment plants, it's about becoming neutral in terms of cost, energy and carbon. There's a number of initiatives that we've got up and running and some that we're still planning to do, but if we look at concentrated thermal energy, this is quite novel and new, and it involves heliostats and using heat for biosolid drying. You can also potentially use this, and we want to examine the potential for it to sterilise sludge through pressure cooking and rapid decompression. to allow that sludge then to meet the most stringent of land use requirements. We're liaising with the CSIRO on that, and ARENA, which is a renewable energy agency here in Australia. Some of the things we're looking at would involve the footprint size, the current state of the technology, what our OPEX and CAPEX requirements would be. We're investigating a regional resource recovery facility, looking at a number of locations. So what would the volume and type of organic matter be? What would our gate fee profile look like? Licensing, state government requirements, and again, the CAPEX and OPEX requirements here. FOG, for those that aren't aware, is food, oils, or fats, sorry, oils and greases. And obviously that's tied intimately to the resource recovery element and helps add some food stock to our waste to energy and resource recovery requirements. Nitrite shunt is a little bit of code, I guess. Without getting too technical, it involves stopping the ammonia conversion from stopping the ammonia conversion going to nitrates and holding it at nitrite. This converts it to nitrogen, and that will reduce our OPEX, our carbon, and our chemicals. We're looking at various solar panel installations. Again, it's green energy. It's about the footprint requirements. To reduce our costs, there's the OPEX and CAPEX requirements. And this one's really about how many kilowatt hours can you produce and where might that be and what does that do for the particular plant in question. We're looking at biosolid disposal for agricultural purposes. There's an interesting question around composting. If you include green waste in your resource recovery operation, what does that do for the process, and what complications does that create for you further down the process when you're disposing of biosolids? We're looking at passive aeration. And how we can improve oxygen transfer on a plastic media in the aeration lagoons and basins. That will help us reduce our electricity costs. There's some interesting work going on in trade waste characterisation. So what does our trade waste profile look like? We really don't look at it in any detail right now, and I'll come to that a bit more in the intelligent operations element of the presentation. But trade waste characterisation is about understanding exactly what we get and when we get it. And is there an opportunity to hold on to that, store it, and then reinsert that back into the sewage network and into the head of the various plants to help smooth out the operation of our sewage treatment plants? Because as everybody knows, the idea is to try and keep them as smooth as possible, and it's the shock that comes from trade waste insertions that can become a problem. We spent about $4.5 million on 67,000 wet tonnes of haulage for our biosolids, obviously doing what most water utilities are in the market doing with that to try and reduce that. And here's one that's a little bit out there, the hydrogen generation. We're currently talking to some research agencies and some potential partners where you can introduce electrolysis to sewage and use that electrolysis to separate hydrogen and oxygen, potentially harvest the hydrogen, and there may be a market for that. So there's a lot in there, and I'm going through quite a bit, but I am very conscious of time for everybody as well. So there might be some questions come up a little later on. If I jump to the next slide. The next slide's about our intelligent operations. And here what I'm really talking about is looking at if you take our roughly 12,000 kilometres of combined sewer and water network, it's currently what you might call dumb and passive. And how can we make that smart and active? How can we know about events that are occurring in our water and sewer network before our customers tell us? I think it's incumbent upon a really smart water utility to be able to know that and not have to wait for the customer to inform them. So I'll go through a couple of these again reasonably quickly. If I focus on sewer monitoring, we're looking for live online sewer monitoring for odour, picking up trade waste transgressions, seawater ingress, identifying odours potentially before they even occur, and if they do occur, certainly knowing about them before the customer does and informs us. And also there's some intelligence in there with some analytics around asset degradation. If you know what the profile of your content of your sewer pipes is, and you know what your sewer pipe condition is and what it's made of and how old it is, there is some technology there that can assist us with determining what our sewer profile is doing from an asset condition perspective. And obviously that kind of intelligence also has an added benefit, because not only are we fixing something for the customer immediately, but the long-term saving in terms of deferring capital, and that saving potentially being passed on to the customer by reducing bill increases is an important element of that. We're also looking into acoustic leak detection. We've had the kick-off meetings for this and the previous sewer monitoring, so these are now up and running. Our acoustic leak detection, I guess, will complement what I would argue would be industry-leading application of Takadu. It will certainly improve the detection resolution of our leaks in our networks to go beyond just the DMAs down to very small sections of pipe. We're going to run both a fixed and a mobile excuse me, leak detection system, which will be integrated in through our control room. Excuse me. Tied to that are our digital meters. We're currently running a trial. It finishes in June. We'll have some information that will tell us regarding a digital meter trial. It's extremely important to us because that's integrally linked to the Takadu system, potentially, and integrated through the control room. And if you put or overlay acoustic leak detection on top of that, you've got a very good profile of your leak detection capability in your network. We're looking at pressure transient monitoring. So live pressure transient monitoring will allow us to look at what is going on in the network in terms of pressure changes. I think that, like most water utilities, we suffer self-inflicted work where we've got either capital projects or our own staff on maintenance work that could potentially send a pressure shock through the network. With a system like this, and again tied to Maximo and coming in through the control room, we know exactly what's going on. This will also be tied to the ability to modulate PRVs in the system, so we're into some live detection of pressure in the network and the ability to manipulate that, and that will be of significant benefit to us. We're looking at sewer manhole level monitoring, again live. Our ability to predict wet weather overflows, to be able to manipulate the pumping in our sewer network and get more predictive rather than reactive as we currently are. So there's a number of things in there, and again, it's about creating some intelligence in the network. Just on that, there is live online water quality monitoring there. We're currently engaging with the CSIRO and looking at other organisations that might assist with us and look at, I guess this is the holy grail of water quality monitoring, and that is online live detection for E. coli. It's a struggle, obviously, for all water utilities at the moment to have to wait 48 hours for results to come through. So what can we do from a live online monitoring perspective by looking at precursor indicators that will tell you that E. coli is about to occur? So if we then jump to the next slide. If I just talk a little bit about the customer here, when I guess there's a number of initiatives there, such as the one view of the customer and the Save Water, Save Money initiative and the automated customer interactions. We have a number of customer systems in the business right now, and I guess trying to pull those systems together and give our customer-facing people one view of the customer data, the customer interfaces, to allow our customers to have a single channel whereby they can talk to us, understand their water behaviour, their water consumption, to make it easier for them. And we're currently assessing new and emerging technologies to help us in that space as well. I guess the automated customer interaction stuff is, the bots and other things. This is right at the cutting edge now, where we're trying to find the ideal solution for our purposes for virtual assistance for our customers online and ramping up self-serve capability. If I jump through to the next slide, I guess this just summarises where we currently are with some of these, and I'll use some terms just to, like, maturing the sponge, the butterfly, nailing it and stitching it up. And the intent here is to try and move everything towards the right. the end of the day, we're doing it for the customer. We want to be able to pass those savings on through our OPEX reductions and our deferred capital. I guess if I was to summarise all of our efforts, one of the things I haven't talked a lot about is the word integration is featuring a lot in our deliberations here and with all of the trials. The key challenge is you can take a number of systems and you can implement them, and it'll give you standalone knowledge of that particular aspect. But the magic happens when you can bring it all together, and that'll be one of the challenges for us. I guess to finish it off and to throw back to you, Hugh, I don't think Unitywater will never be the biggest water utility in Australia, but we intend to be the smartest. That's our plan, and it's the clever use of the technology that we're looking to leverage off, and we're getting a lot of interest in the things that we're doing. We've got an extremely engaged board and CEO. We've got a lot of support through the business. We're young and nimble and agile, and I'd like to think that Unitywater will be certainly shining a light on some of the smart ways that technology that's already proven can be leveraged off and how it's integrated and brought together. Thank you.
Great, thanks for that, George, and to Rob. And as a reminder, and for those that have joined more recently to the call, questions can be asked in the chat box on the right-hand side of your screen, and these will be collated and asked at the end of all three presentations. And we do see a number of great questions coming through already. Our next presenter is Mr. Jiawai Ying from PUB in Singapore. And Jiawai is going to be discussing how PUB has developed a smart utility and is getting ready for the future. Jiawai, you have the floor.
Thank you, Hugh. Good day to everyone from wherever you are. My name is Jiawai and I'm from the Smart PUB Program Office. For the next 15 minutes, I'll be sharing a bit on some of our Smart PUB projects. Okay. To start off, I would like to introduce to you the little red dot on the global map, Singapore. Alright, so water has been Singapore's existential challenge. So because Singapore is a small country, we are very limited in terms of land area, and we have a lack of natural resources and water supply. So in 2015, in fact, the World Resource Institute ranked Singapore as one of the most water-stressed countries in the world. And currently, half of Singapore's water needs is actually met by imported water from our neighbor, Malaysia. And water sustainability is going to be an existential challenge for us. You can see that although we are at the heart of the equator and in the tropics, we receive a lot of rain, but certainly we do not have enough room to collect all this water. So business as usual is not sustainable for Singapore. We have to innovate. We need to leverage on smart technologies. So some of the drivers for smart PUB, we need to increase our water resource. By 2060, we will actually double our water demand as what we are currently consuming. Our national water consumption is at about 400 million gallons a day. And in 2060, we will double it to 800. And bear in mind that in 2060, our water agreement with Malaysia will also expire. So we need to find the next drop of fresh water. And number two, we need to protect our water quality and security. Maintaining good water quality is increasingly getting more and more challenging. Number three, of course, we need to find ways to reduce production costs. As we double our water consumption in 2060, the projection is that the energy footprint will actually triple, right? And then energy footprint will actually increase from 1.7 to 2.5 kilowatts hour per cubic meter. I meant the energy consumption, the total energy consumption will actually triple from 10,050 to 3,200 gigawatts hour per year. In terms of sludge, we will look to double actually to more than 600,000 tons a year. And in terms of land use, the siting of infrastructure is getting more and more increasingly challenging because there's competition of land in different industry. In terms of manpower, we have a shrinking workforce, and there's higher expectation from the public as well as from our own staff. People are getting bigger aspirations. They want to be involved in the management and executive. So we want to deploy robotics and automation to help some of our manual work. So we're looking at 5 main technology enablers to help us achieve that. Of course, IoT, getting data, getting pervasive sensing, getting connected through sensors and devices. And then with all this data, we're going to fit it into our data analytics platform that will give us new insights as we harness this big data. And then with these new insights, we're able to fit them into simulations and models to give us insights and plan for what-if scenarios. And then we also look into artificial intelligence, that is machine learning for decision support systems. And finally, autonomous systems to replace manpower for the dull, dirty, and dangerous work. So I'll go into sharing some of the initiatives that we have implemented in PUB. Okay, first up will be this silt imagery detection systems, which we call it SIDS. What it does is that it helps to prevent muddy waters, from construction sites to flow into our waterways and reservoirs. So this technology, simple technology using CCTV, has been implemented since 2013. So now we have mandated it, we have legislated it. So contractors of construction sites are now required to install CCTVs at public drains to monitor the stormwater runoff from the construction sites. Instead of having people manning and looking at your CCTVs, we have actually implemented image analytics to flag out any anomalies or high turbid waters flowing into our drains. So some 800 CCTV cameras have been installed by the contractor so far. Earlier this year, we actually collaborated with one of our universities to implement this analytics to automatically monitor the CCTV footages. So SIDS has actually helped PUB streamline our enforcement efforts. Before SIDS, PUB will have to conduct random checks based on CCTV records. And this can be quite sensitive and problematic goes to when we need evidence for prosecution. So with SIDS, PUB can monitor the real-time data from CCTVs and prioritize problematic sites and follow up them. So far, we have actually detected more than 150 cases from around 500 CCTVs since 2016. Next, I'll share a bit about our water supply network. So we've implemented this smart water grid with the objective of helping PUB supply good water 24/7 to our customers. So we have now more than 320 sensor stations, which covers 75% of our network today. And we're able to better feel the pulse of our network by constantly monitoring the pressure, flow, and quality of our water network. So using this information, we actually detect the pressure and water quality anomalies. And we're able to leverage on data analytics to forecast water demand, as well as model different scenarios, so as to better support our planning, operations, and also maintenance works. So some of the benefits as highlighted in this slide include pressure management, leak and burst detection, operation simulations, hydraulic modeling, demand prediction, and water quality monitoring on a real-time basis. And these are new capabilities that we're developing as part of our Smart Water Grid project. So we are still at the beginning of our Smart Water Grid journey, I think, and we believe that challenges still lie ahead, in terms of quality, reliability of the sensors, as well as the pattern recognition, the accuracy, and the analytics. So we look forward, to work with more companies and technology providers to test with our solutions in our operational conditions. Okay, next is on smart meters, right? Smart meters help PUB in our data-driven customer engagements. So even as we seek to enhance our water supply management, we actually recognize the very need to cultivate water saving habits. As we mentioned, we have very high water consumption within a very small area. Singapore is one of the most population dense country in the world. With a high water demand, we have the hardware available. I mean, the technologies that we're going to deploy to help us with our water supply. But at the same time, we have to engage in public and educational and engagement platforms as a hardware to induce water conservation behaviors. So water meters can actually provide residents with real-time water usage data. So residents and water users are empowered to make sustainable lifestyle choices. And on top of that, incident alerts can also be sent, to immediately to inform customers if there are any suspected leaks, in their household or their taps are left running. So the app, we've developed an app, will actually send a notification. And with this data collected, we can understand from a PUB's perspective, we are able to understand our customers better by analyzing their consumption patterns, and we can do customer segmentation as well as customize engagement activities and strategies to achieve better results. Okay. So also on the topic of smart water use in residential context, we are now rolling out smart showers, and we want to drill down to the individual water usage areas within the household. So in Singapore, it's hot and humid all year round. We have a temperature of about 32 to 34, 35 degrees Celsius every day. And so a typical household uses as much as 30% of their water for showers. So people take showers like maybe twice a day. Yeah, sometimes 3 times a day, depending how hot the weather is. So PUB relies on technology improvements in the design of shower heads to try and reduce shower water usage while maintaining comfort levels, while not jeopardizing or compromising comfort, of course. So earlier this year, we actually conducted a trial with a university to collect data with 500 households, and so this water consumption meter were installed in their shower heads so that the end users are able to be aware of how much water they're actually consuming while the shower tap is left running. And some of the results from the trial showed that actually providing real-time feedback helps users to use less water per shower. Probably it's psychological, but it is useful, it seems. Yeah. And we have achieved some 5 liters per day per capita of water after installing, as when it's compared to a control group without having these smart meters installed in the shower. So we see the great potential in providing real-time data and feedback to our end users. We think it's powerful, it's very cost-effective, simple and affordable device to influence water usage behavior and help households save water. So on the topic of plants and smart plants and our operations, embracing smart technologies to enhance our operation and maintenance, looking at IoT sensors, vibration sensors, which we install actually on our rotary equipment such as blowers, pumps, compressors, to just give us a real-time assessment and condition sensing of the performance, energy, efficiency of this equipment. So with this real-time data, we're able to better plan for the maintenance. So it's a predictive maintenance rather than a preventive or even corrective maintenance. So we monitor the pump performance through these IoT sensors, and then we pass all this information through a data analytics platform that will actually analyze, do some signature patterning, and they will be able to tell us, okay, if a pump or a specific, say, a compressor is going to fail, that will help us avert any catastrophic or major failure. So currently we have about 100 of these sensors installed in some of our plants, and then we are actually analyzing this data for trend analysis, and it will also help us set trigger points for different equipments, better trigger points, not too conservative, not overly conservative, or excessive, or too little. So you're able to better optimize each maintenance schedule. And like I mentioned, it provides insights before the equipment needs to be serviced, before any failure. Right. Then I move into robotics. Some of the projects that we have done using drones. One of the areas that PUB is looking at very actively is using aerial drones beyond its capability of just collecting images, but also as a sensor, as a mobile sensor, to collect data, especially spatial information of our water quality in the reservoirs and large water bodies. An example here is the hyperspectral technology used to monitor water quality in reservoirs. They can actually be integrated with a drone for more flexible use, and then it overcomes the constraint of a fixed system. Before installing these hyperspectral cameras on drones, we initially had a phase 1 project where we actually installed permanent hyperspectral cameras on our reservoirs at different strategic places of our reservoirs. It captures data, water quality data. It does aquatic mapping, turbidity, chlorophyll A readings, of our water quality in different pockets of our reservoir, which was very useful to us. So to take it one step further, we're now implementing drones to actually deploy, to actually have this hyperspectral deployed on them. So in summary, I wanted to share that the integration of smart water technologies across Singapore's water loops is a vision and our future for water management. It has to be integrated as a whole to derive the synergies and benefits. And it is something that is driven by innovation, and we want to be informed by the data to make informed decisions. So PUB aims to manage the water loop more productively and efficiently. We need real-time feedback and analysis for better sensing. We need to have accurate simulations and models, to allow us to preempt and manage any potential upsets or impacts. And we also want to apply the latest, most advanced technologies to further automate our process. This is expected to improve our planning and operations and service delivery to the public. This slide shows an integrated smart water loop, which you see. The vision is that a smart operating system is built by several smart subsystems that are working in tandem and in sync with each other. So in PUB, we actually manage the entire water loop from the first drop of rainwater that falls in Singapore. We collect it via our drainage, our canals, sends it to the reservoir. From the reservoir, we treat this water at our water supply plants. The treated water, the potable water, is then supplied to the taps, to the industries, to the residential areas. And then we collect, of course, this used water, this drinking potable water is supplied via underground asset of 5,000 kilometers of network to our end users, and then it is collected by our water reclamation network, which conveyed to our water reclamation plant for treatment, either for discharge, outfall, or some of you may have heard about Unitywater, which is a high-grade reclaimed tertiary grade water, reclaimed water, which is supplied to the industry for direct in potable use, and some new water is also used to charge our reservoirs. And then wanted to add that all of our operations are actually underpinned by a sound foundation of operation support and digital workplace, which we are also in the process of digitalizing and transforming to better support our operations. So this is my last slide, the concluding slide. As I mentioned, business as usual is not going to be sustainable for PUB and for Singapore. We need to integrate an integrated and proactive management of PUB infrastructure and assets. As with today's workforce, we have about 3,000 3,000 strong staff. We need to upskill them to embrace, for them to embrace technologies. And right now we're doing a lot of technology deep diving. We're engaging the industry a lot and to develop solutions for us. And these solutions are not immediately deployed in full-scale installations. We typically do piloting and validation and small-scale setups, either in a pilot plant or a demonstration plant, before we scale them up further. And then when we are confident, we will then specify these technologies in our full-scale tenders. Yep. With that, I end my presentation, and thank you very much for your attention.
Thanks, GY. I really appreciate that. On to our final presenters, Mark Teixeira and Nish Dogra from Watercare in Auckland, presenting on the smart water network that's been set up in the Auckland CBD. Mark and Nish, floor's yours. Thanks.
Hi everyone, I'm Mark Touchette. I'm the IoT product owner in digital for Watercare, and I've got with me Nish Dogra, who's our smart water special projects manager. Now for those of you who don't know, Watercare is Auckland, New Zealand's water and wastewater provider. Now Rebecca Chenery unfortunately couldn't make it tonight, but she has recently been appointed as our Chief Digital Officer, reporting to the CEO, which is really good because we had a real push from our board and CEO for Watercare to become more digitally enabled. So we're soon going to be developing an IoT strategy, and it's great to have her on board. But this particular presentation, so we have implemented an IoT pilot. So this presentation is about this pilot that's monitoring our water network in the CBD of Auckland. So when we were looking at this, there were many business drivers and issues we were trying to hopefully fix with IoT. So I'll take you through some of those. So we really wanted to move from being reactive to proactive when managing major leaks and bursts. We wanted less reliance on customers having to call us to tell us about these big leaks. And so we looked at the CBD because it's primarily hard surface and leaks are not readily seen. And there's actually a lot of constructions happening in Auckland at the moment. We're extending our rail network into the CBD. So as you can imagine, a lot of underground tunneling. And there's also a lot of just general building work happening. So we wanted to understand the risk of damage due to this increased construction. We wanted real-time identification of it to enable us to go to those third parties and where applicable, recover some costs from them, but more importantly, being able to get onto these issues as soon as we can. We also wanted to identify people accessing our network, like hydrants, adjusting valves, wanted to reduce dirty water and theft of water, which unfortunately does happen. So there were a lot of business drivers that we were looking at for this IoT project. So the solution we implemented was a sensor-based solution to collect high-frequency pressure and acoustic data. And it measures the pressure 256 times a second and acoustics hourly. We'll put 15 pressure sensors placed to cover 130 kilometers of pipe works, and each sensor typically measures around 9 kilometers of pipe works. We also installed 15 hydrophones for acoustic data to look for those small leaks in the network. And all this data is collected, and the analytics is provided to us by our chosen vendor for this solution. So the key features of this solution is really to be able to report the status of the network and the analytics provided by the data. And a very important one, to be able to get notified of events within 30 minutes of them happening. And we also want to predict future failure points due to water hammers in the network. And this enables us to track network changes a lot easier. So what I'm going to do now is pass you on to Nish, who's going to tell you a little bit about how this works.
Thank you, Mark. Hello, everyone. My name is Nish. I'm going to take you through to the next few slides, covering a bit of technical aspects of the solution. Looking at the slide right now, these are the 15 locations we chose for our logger layout. So the way it was chosen was the GIS data was used to strategically place these 15 loggers to ensure we have the maximum coverage using the minimum amount of loggers. The logging equipment that we used in each of these locations is shown on the next slide. So starting from the left, the first big gray box is the waterproof battery enclosure. This is where the 20 amp battery sits. Now at Watercare, we always strive towards achieving sustainability, and that's why we chose a solar solution to recharge these batteries, which I'll show you on the next slide. The second thing in the center is the hydrant cap that goes onto the hydrant. Now attached to this hydrant cap is a hydrophone and a pressure sensor. So the hydrophone, the black part on top of the hydrant cap sits inside the water column once it's on the hydrant. So what that does is basically cuts out any outside noise, any external noise through traffic or foot traffic, because CBD is a busy place. So that was very useful to make sure we get a good acoustic data log. And the third is the RTU unit, which is a remote terminal unit on the right. Now this is the actual data logger in which is all the collected data goes in, and it's got a cell phone SIM in there, and all the data is sent into the cloud via the cell phone network where all the analytics takes place. So this is the typical installation we've got in CBD. Now initially all of these equipment could fit into the fire hydrant, but since we wanted to go for a sustainable solution of a solar panel, we couldn't change the design of the existing fire hydrant lids because of the legal requirements. It needs to be yellow. So what we did was we installed an extra solar panel lid and an extra meter box right next to it where all the equipment's placed. And there's a conduit connecting these two boxes through which the cables go from the hydrant to the logger and the battery units. Now the solar panel lid itself is quite rugged. And the way it's set up is you can drive over it, walk over it, and it still doesn't damage the solar panels itself. Now the next slide is this very simple diagram showing the process, how it actually works. It's a very simple graph. So the basic thing you can pick up straight away from the graph is a lot of the process is quite automated. So a lot of analytics that takes place, it's automated, and there's only a bit of manual intervention required. So basically the way it works is the data is collected by the logger for pressure data and acoustics data, and it's sent into the cloud where all the analytics take place. Now within the cloud, the transients, the leaks, and any pressure changes are identified from the data. Now all these issues that are identified are ranked from 0 to 10, now 10 being the worst issue, after comparing the data from the neighboring sites to correlate what the issue is, and by looking at the historical data to make sure it's not something which is quite regular in the network and it's actually an event or incident that's taken place. So after that, all the issues that were ranked 6 or above are flagged into the system, and this is where the manual intervention comes into play. The control room is manned 24/7, who looks at these flagged data flags, and they do the final verification and send an alarm back to us just to make sure what they've figured out is actually an event or not. Now what they do is they send an alarm using a text message and an email. An email has the detailed information about what's been picked up, what they think it is, and where the approximate location of the fault may be as well. What we also get is we get monthly reports from a vendor. Now these monthly reports include information about how our network is behaving, any slow leaks that may be forming in the background, any damaging transient activity or water hammers that may be occurring in the network. So what we do is for any immediate events like leaks or bursts, we dispatch our contractors to have a look at the situation and fix them as required. For any information that comes in monthly reports, we do our planned investigation if further investigation is required, and then we take remedial steps based on that. Some of the lessons we learned while we were implementing the solution and during the one-year trial that we've gone through so far. The first lesson we learned was there is a transitioning or a learning phase after the implementation. This is something we noticed when we started getting a lot of alarms to start with, and then we eventually figured out those were the daily trends and the patterns that actually happen in the system by usage. and they were all false alarms. But after a month, once the system recognizes these as daily occurrences, it starts taking these out of the equation and only flags the correct alarms. So that was a learning phase that does happen when the system's installed initially. The second lesson we learned was a network interference can affect the analytics of the actual software itself. An example of that was there was a burst main in the CBD, literally 50 meters from the loggers, and the logger didn't pick up the burst at all. So what we did find eventually is there was a lot of shut valves between where the burst occurred and where the loggers were, which stopped from the transient activity to travel all the way to the loggers, and that's why the loggers were blind to it. So the network interference can affect your analytics because the system, when the GIS data is given to them, is thinking all the valves are open and it should be going to the logger. But if such events do occur and you have shut valves, it may affect your analytics as well. The third lesson we learned was since we only had 15 data loggers with 15 hydrophones on each data logger, so each data logger for pressure transients can cover up to 9 kilometers, but the hydrophone itself has a coverage of maximum 1 kilometer at its best. So what we noticed was there was a lot of blank spots for hydrophone coverage in between the loggers, and that's where we missed some really small leaks which were slowly developing and were not picked up by the hydrophone. So this is where we think a high-density hydrophone coverage would be great to pick up any small leaks that may be forming in the background. The final lesson we learned was that the quality of analytics that we get is directly related to the quality of GIS data we provided. It's a simple logic of rubbish in, rubbish out. If your data to start with is not that great, then all the analytics based on that may not be that accurate as well. What I'll do now is I'll pass it on back to Mark to go through some benefits and conclusion.
Thanks, Nish. And look, the realized benefits actually largely were delivered from the initial business drivers. We were able to substantiate third-party damages and, where applicable, recover costs. We are receiving live pressure data. We have much better visibility of network activity and performance, and we are proactively managing the network 7/24 now. And the analytics that we have at the moment and the data that we're getting is actually going to be quite useful in the future. So at the moment, we're just focusing on leaks and bursts, but ultimately, in the end, looking at our SCADA information and everything else, we really want to start utilizing all this data and doing some proper analytics. But we haven't figured out how we're going to do that yet. Yeah. So look, we've so far found about 25 major leaks and bursts events, and they've all been identified prior to being notified by the customer. And we've unsurfaced a number of small leaks as well. We're able to identify the origin of water hammers, which we need to know if we want to try to extend the asset life of the pipes. So look, in conclusion, this pilot was actually very successful. And we're now looking at rolling it out in another area with high water users, older pipes, and high pressures. So what I'm going to do is pass you on to Nish, who's going to talk about this next rollout and also talk about another use case where we're going to roll something out in the wastewater network. So over to you, Nish.
Thanks, Mark. So as Mark said, the success of the solution is really good, and we really like the solution. It works really well. And out of those 25 leaks and burst events we found, we noticed most of those were found into the area where we had aging infrastructure and we had regular transient activity happening there all the time. So what we thought was and we also had an example in CBD where one industrial user was causing huge transients. Luckily, they were not causing any damages in the immediate vicinity because we had brand new pipe network. It may be reducing the life of the asset itself, but no damage was done by the transient, but it had the potential to cause damage. So the three things we picked up is high pressure transient activity, water hammers, combined with high water pressure in the system and aging infrastructure is a recipe for disaster. And that's where you notice most of your leaks and bursts. So what we're trying to do is we're trying to implement this solution into one of our zones, which has the highest water users in Auckland. Very industrialized area. and we may be getting a lot of damaging transients in there because we have a very old infrastructure in there as well, a lot of old AC mains, and a very high pressurized zone as well. Now, combine all those three, we actually seen a lot of bursts and leak events in that zone in the past, and we think implementing that solution there would be really good for us to actually find the source of the transients and take remedial steps to ensure we can reduce the damaging effects caused by those water hammers. The other thing we're going to do, and we are probably the first ones to trial the same solution, which is built for water, into a wastewater network. So we've had a situation where one of our wastewater pipes, which is a pressurized or pumped wastewater mains, runs very close to a stream, which is not very visible to the naked eye. And if a leak and burst does happen, it goes unnoticed for a while, and it leaks right into the stream, which is a major environmental issue as well. So what we've done is we implemented the solution on that pipework, and we are hoping to get the same results from the pressure transients, that if a burst or leak does happen, we'll see the loss in pressure, and we'll be able to pick that up much easier and proactively before someone actually calls it in, and we can do something about it to reduce any harmful environmental impacts and actually do good before the wastewater network as well. What I'll do is I'll pass it back to Mark to conclude. Thank you.
Actually, thanks, Nish. That was great. So I'm going to pass it back to Hugh now for any questions.
Thanks for that, Mark. So we've had a number of questions coming through during the webinar, and I am mindful of the time. But for those that can remain with us, and I hope the presenters can remain with us for another 10 minutes or so, we will try and get through as many as possible. The first question I have here, and if we can, presenters, please be prompt with your answers so we can get through as many as possible. For Unitywater, how do you currently undertake water quality monitoring?
It's manual sampling, so we have people in the field taking water samples, measuring for both chemical and biological, and we have a laboratory of our own where the samples go.
Great. Another question for you, Rob, and for your team at Unity is, what are the initial outcomes from the digital water meter trials?
Sorry? Yeah, just go. No.
Look, we still haven't had a formal wrap-up, but the initial trials is that we've been able to successfully get the data back from the field. So there's been minimal data loss. And we've also seen that there's been a strong uptake from customers accessing the portal that they were given in order to be able to track their individual consumption patterns. We haven't necessarily done any analysis at the moment to see whether that is any different to the pre-installation of the smart meters, but that's a piece of work that will be happening over the coming months.
Well, we've got the Unity guys. We'll go through a couple more here. So what is your typical sampling rate for data logging? And is real-time monitoring important, or is it sufficient to send the data a few times per day?
The sampling rate and for the monitors can vary from anything to 1 second to, say, 15 minutes. The challenge is how quickly do you want the data back? So it's the send rate. So in other words, a sensor that can be measuring for anything, whether in the sewer or the water network, and whatever it's looking at, it can store that and hold it. It's your send rate and how quickly you want that data back to the control room is going to be your determining factor for battery life. And with battery life, you can get up to 5 years now. That's getting quite sophisticated. And there's not a particular need to have some alternative supply there through solar panel. So it depends on what you're looking at or looking for and how quickly you want that data back and what's that going to do for your battery life. So it's a case-by-case basis.
Look, I'll just add to that what we're finding with our leak detection in our networks, and we've got 95% of our water network covered with sensors for identifying leaks that don't come to surface. What we do currently is we collect that data on a minute-by-minute basis, but it's actually packaged and sent on the hour. So we actually, and the cost of doing that is cheaper than what it was 5 years ago when we packaged the data and sent it every 24 hours. So in essence, we're sending data every 60 minutes and getting a response 60 minutes later on full analysis of the network. So we're able to see in close to real-time deterioration of the water supply network for the purpose of leaks every 60 minutes. And that is cheaper than what it was 5 years ago when we were doing it every 24 hours.
It's going to continue to come down.
Yeah.
Great. A final one for you guys at Unitywater here is if you could just explain a little bit about the dynamics between the utility and the research organisation you mentioned. For example, do you fund them?
Currently, we're in the early stages of those conversations, and it's, for example, with the CSIRO and others, and so it's a little early to tell, and we might get into some proprietary subjects here, but the bottom line is that it's a little early, and we're looking to gain. I guess we've got a backyard that some of these companies can play in, and we provide that. And there might be some other organisations that would look to come along and join us from a funding perspective, and other organisations that might come along to join us for the research capability that they bring, and that is dependent upon which of the trials that you're referring to.
Great. A similar question for PUB. So GOI, we have a question for you around, how do you fund the testing of new technologies?
Okay.
Can you answer that? How do you fund those initiatives?
So in PUB, we actually set aside a portion of our revenue, from our water sales to do R&D. Like I say, business as usual is not sustainable, so we have to invest in technology development. So we work closely with the industry to co-fund development and testing of technologies in our backyard, in our operating conditions. So it's always win-win situation for us and for them to gain a track record. For us, we get to validate the technologies, And also we work closely with other government agencies. We have a National Research Foundation, and the Singapore government sees water research, water industry as a very big and important growth engine for the economy of Singapore. So they do fund us quite substantially to support some of our pilot testing.
Right. We have a question here for Watercare. How many bursts before the implementation of the Auckland CBD Smart Network did you have in that area per month?
Per month, I wouldn't be sure how many, but we do normally see 4 to 5 bursts. But the new area where we thinking of implementing it, that's quite high. We normally see 20 to 30 bursts in that new area where we want to implement. The only reason CBD was used as a trial was because there was a lot of third-party activity like the CRL project, and a lot of construction projects were going to take place within the last year and continuing on till next year as well, and that's why we chose CBD. In CBD itself, I'll say 4 to 5 bursts were the maximum we would ever see in a month. It's just for more of the protection of the assets and just to identify what happens while the construction was happening. That's why this trial was chosen for CBD.
Another question for Watercare is around, with all these smart technologies, what's the backup if they fail? How critical is contingency planning, or are these technologies that you've deployed fail-safe?
They're not fail-safe. They do fail sometimes, and communications or the battery, something might happen to the battery as well. So what we do is, as part of the agreement with our vendor, there is a live monitoring for the loggers. So if they do go flat or something goes wrong with them, there is a local vendor in place in Auckland. What they do is they go out and they fix the issue. If backup monitoring is required, we put more data loggers in there just to make sure we don't lose any data while the existing data loggers are being fixed. So there is contingency plans. They're not as live as the existing system, but if it does fail, we do have backup plans and we can get extra loggers in there.
Following on from that question, the same attendee asks regarding the solar panels, is there sufficient to supply the sensors with electricity, or is there some other considerations, e.g. hours of sunshine, etc.? Can you just provide some commentary on that?
Definitely sunshine is important. It does charge the batteries quite a lot, but after a while they do die. What it does is it does provide a longer life than we would have got from the battery. So, for example, I'm just giving an example. If we were meant to get 3 months out of it, we were managed to get 6 months out of the same battery using the solar panels. So they do charge the batteries.
A question here regarding IoT. for Watercare again, how important is IoT compared to 3G or 4G networks?
Look, IoT is something we're just getting into now. So the business has largely been driving these projects that Nish has been talking about. So we're just kind of really getting into it now. And I think IoT will be very important. And, you know, 3G, 4G is kind of the technology, the communications behind that, or there are others as well. So yeah, there's going to be a big push going forward, but IoT, I would say, is more important.
Another question for Watercare. Have you experienced any operational problems with the hydrophones?
No, we haven't experienced any operational issues, just apart from the fact that they do have minimal coverage compared to the transient loggers. So they work really fine when they do find leaks around them. In fact, they've been really good, especially the ones that go inside the water column are much better than the traditional acoustic loggers. Since what they do is, since it's sitting inside the water column, it actually is much more accurate than the traditional hydrophones we've seen. So we haven't had any issues. The only thing that we could do better off is having more of those hydrophones. So we have much denser coverage of small leaks as well.
For Unitywater, I believe this one's for you. Have you thought about having low-powered wide area network level sensors in the wastewater network to identify changes in levels?
My silence is me thinking about the question, to be honest. I might take that one on notice and get back to the the person who's asked it, if that's all right.
Sure. So we have had a number of questions come through that we're not going to be able to get to today. Just as a reminder, a recording of this webinar will be available probably tomorrow for attendees to revisit or pass on to their colleagues. So with that, we're going to conclude the webinar. Thanks everyone for attending. On behalf of the SWAN APAC Alliance, in particular, thanks to our presenters from the three organisations. We welcome your feedback on what we can improve here, and we obviously take these learnings around the technical aspects as well. We also look forward to your feedback on the future topics of interest so we can improve and provide greater value for our members. So with that, thanks very much, and we'll be in contact again soon. Thanks all.